To cover something about prescriptive analytics or optimization or decision making. Next week we review the course and I give you some, for example, question about some structure of the question for the last assessment, which is due on week 30. We talk about the assignment 3 and the structure kind of take-home exam. We talk about that next week. This week we want to talk about prescriptive analytics. You remember in the business analytics we had descriptive analytics, predictive analytics, and then the last one is prescriptive analytics. When we talk about prescriptive analytics, it's actually the action. You want to make a decision. You are in the decision making situation and you want to make a decision. There are several techniques for decision making. One of the main techniques in decision making is called optimization. Optimization is some methods that they are used for decision making. Usually when we talk about the decision making, in the general, when you want to make a decision, what is the logical process of making a decision? When you want to make a decision, you set some criteria. You want to meet those criteria. You say, I wanted to make a decision to, for example, use most of my time. I want to make a decision such as, for example, for the holiday, you want to make a decision that you get most of your holiday. Therefore, when you want to make a decision, usually you have some criteria you care about. In the terminology of the decision making, we call it objective function. You have some objective you want to achieve, and you want to make a decision such that those objectives achieved. When we talk about the optimization itself, there are several methods in optimization. It's very vast area of knowledge and science. There are lots of techniques of the optimization. Some part of optimization is called constraint programming or linear programming that we cover part of that in this course. Before explaining the solution, I want to start with one example to give you some idea about what is the decision making look like, and then this Excel file is on Blackboard. It's in content of week 11, it's on Blackboard. I want to explain this Excel file and then we solve further problem. The file I opened is one of the files I put in the content of the week 11. The name of the file is optimization example week 11. This is the situation of manufacturer. I explain it here. Let me just remove this. Assume there is a manufacturing and the manufacturer produced two items. Is it better or? A manufacturer produces two items, item A and item B. The demand for current months for item A is 80 units. If they produce 80, they can sell it to the market. The demand for item B is 60 units. When they want to build this item, they have to use two machines. For building item A, it needs 2 hours of machine A, machine 1, and 3 hours of machine 2. Therefore, if you want to manufacture 1 unit of A, you need to use machine A for 2 hours, and then there's a sequence of machine, and machine 2 for 3 hours. For item B, if you want to make 1 unit of item B, you need to use machine 1 for 3 hours and machine 2 for 2 hours. Yeah? And profit of each unit of item A is $5. You get $5 profit for item A, and you get $4 profit for item B. For the current month, this is the explanation of the problem itself. For the current month, machine A is available for 160 hours. But machine 2 is available for 150 hours. Maybe for 10 hours it needs to be serviced. It's not available to make production. In this problem, we want to make a decision. And our decision is how many unit of A we produce and how many unit of B we produce. This is a decision-making problem. What is the objective? If you are, for example, you are manager of this company, you're producing 2 types of items, this is the profit for each of them, but you have limited resources. You have 2 machines, and this is the usage of each product or each item from your machinery workshop. You want to make a decision, say how many unit A you produce this month and how many unit B you produce this month. This is the problem itself. Is the problem clear to everyone? Do you understand what you want to make a decision about? We want to make a decision how many of each of these you need to produce. If you want to make such decision, what is your objective?
Profit.
Maximize the profit. You want to find the best possible things to maximize your profit. Therefore, the profit, you care about the profit. You want to see how to make a decision to maximize your profit. In some cases, for example, you want to maximize your profit. Some cases you want to maximize the customer satisfaction. In some cases you want to maximize the sustainability. You might have different objective function in different decision-making problem. In this one, it's very classical problem in decision-making. You want to maximize your profit. Yeah? Okay, what is the profit? If I say, for example, let's say I produce 10 units of A and 15 units of B, just randomly. Just put two random numbers. I'm going to say 10 units of A and 15 units of B. Yes? Just 2 random numbers. What would be the profit for this case? The profit is I'm creating 10 this unit times this is the profit of unit A, yeah? Plus I'm creating 15 units of B times the profit of B is this one. This is the objective. My objective is profit, and profit is calculated like that. It is number of unit of A that I produce times the profit of unit A, which is cell F4, which is $5. This is the amount of number of unit B I produce, and the profit for unit item B is $4. If I click enter, my profit would be $110 based on this decision. Based on this decision, my profit is $110, and this is the formula for profit. Makes sense to everyone? Okay. Do you think it is good solution or not? This is good decision or not? When we want to say the decision is good or not is a very not technical word to say. You need to check 2 things. First, this decision is feasible or not. First, we need to check whether this decision is feasible or not. Do you think creating 10 of A and 15 of B is a feasible solution or not? What is the meaning of feasible solution? The feasibility means, given the amount of resources that you have, can you make this decision or not? For example, you have 160 hours of machine 1, and 150 hours of machine 2. With those resources, this is the availability of your resources. Can I make this decision? If I can, it is called feasible solution. I can say this is feasible. How I can check whether it's feasible or not? Let's see. Let's come and see here. If I write here usage of machine 1, and here I write usage of machine 2. Let's calculate the usage of machine 1 based on this decision. If I produce 10 unit of A and 15 unit of B, how many hours I use my machine 1? Do you think I should say I produce 10 of A and 10 of A, each of them require 2 hours of machine 1. Plus I produce 15 of B and it requires 3 hours for B. This is the amount of usage for machine A if I make this decision. If my decision is creating 10 of A and 15 of B, how many hours I need from machine A obtained from this formula? Why this formula? Because it says if I create 10 of A, each unit of A needs 2 hours of machine 1. And 15 of B, each unit of B needs 3 hours of machine 1. Therefore, this formula gives me the usage of machine A. Do you agree with that? Any question? Makes sense? How many hours I need machine A if I'm going to use this decision? 10 times 2 plus 15 times 3. Because for each unit of A, I need 2 hours of machine 1, and for each unit of B, I need 3 hours of machine 1. Okay. Enter machine B again. For each unit of A, type A, I need 3 hours of machine 2, plus for each unit of B, I need 2 hours of machine 2. Same thing. I want to calculate the usage of machine 2. These are my resources. Okay. If I click enter, here you see, if I'm going to implement this decision, I need 65 hours of machine 1 and 60 hours of machine 2. Is it feasible solution? Yes, it is feasible because I have 160 hours of machine 1 available and 150 hours of machine 2 available. Therefore, this decision is feasible. Yes, this is the feasible solution. But the next thing, when you have a solution, first you check whether it is feasible or not. Second, you need to check whether it is optimal or not. Optimal means whether it is best decision or not. Okay, let's see if I change here 10 to 100. This is feasible solution? No, because I need 45 hours of machine 1, but my available resources is 160. This is not feasible. Therefore, go to the Files menu, Options, go to the Add-ins, left side, and then here, from this selection, select Add-ins, Excel Add-in, and go, and then tick the Solver Add-in, and then click OK. If you add this one, you will see the solver in the data menu, you will see the solver below the data analysis. You missed that? Okay. You have Excel open? Okay, let me show you again. Go to Files, Options, Add-in, here, and then at the bottom of you see the Excel add-in. Click on Excel add-in and click on Go. And then click the Solver add-in, and then OK. Then, if it works properly, you should have the Solver at the top of when you click on the Data menu, in the right-hand side on your screen, you will see the Solver. Question so far, anyone could get it? If you don't have it, probably you might already set up it on your computer, but in case. Okay, once we have this one, then you can click on Solver, and it is the way you can solve the object optimization problem with the Solver. Let me, this is the, I remove them. When you open this Solver, it opens it opens this window to you. It's very easy to read these windows. It says the top one is set objective. What is our objective? Our objective is cell B18. Yeah? Because we want to maximize the profit. I can click here and select this cell. Because this is the cell I want to maximize. This is my objective. Because not all of the optimization problem or decision making problem are maximization. Sometimes you want to minimize the risk. Sometimes you want to minimize the cost. Or you want to minimize number of failures. These things, because therefore there is an option in Excel for you whether you want to maximize or minimize or set the value equal to something. You remember set the value is similar to goal seek that we had last time. Yeah? In this case, we want to maximize the profit. We pick the maximize, max. Yes, so far we selected the objective function, we put max, and here it says if you want to maximize that objective function here, what are the cells you want to change to maximize that objective function? This is called decision variables. Therefore, I want to click here. This is my decision variable. I want to maximize the profit by changing these two cells. They are my decisions. I want to change those such that have the highest possible profit that I can have. Okay. Therefore, so far, this is our objective function, this is our decision variables, but we are not finished because we have some limitation as well. Here you need to add your constraint or limitation. I click here and say add. One of the limitation is this is the usage of first machine. Yes? The usage of first machine should be less than equal of availability of the first machine. I click here, this is the availability of first machine. This is in cell F9, I calculated the usage of the machine 1 for this decision. Yeah? Therefore, usage of the machine, which is cell F9, should be less than equal to availability of machine 1, which is cell B9. Make sense? Okay, click OK. We have another constraint for the machine 2. Add again. The usage of machine 2 should be less. You can hear there are different things you can select, but here we want to less than equal. Less than equal to availability of machine 2. Again here, cell F10, which is the usage of machine 2, is less than equal to cell B10, which is the availability of machine 2. If I click OK, Now, in this panel, I have my objective function. The first part is called objective function. Then I have my decision variables. Then I have my constraint. The structure of the optimization problem will work. Objective functions, decision variables, and constraints. Here you make sure you tick this one as well. Because we cannot have negative value for decision variable. You cannot say I produce negative 10 unit of A or negative 20 of B. Therefore, make sure you tick this one. Make unconstrained variable non-negative. Make sure that this is saying that the decision variable should be positive. You cannot have negative value. In most of the cases, most of the real problem with work, the decision variables are positive. Therefore, we tick this one. Make sure you click on this one. Then here, there are several algorithms to solve the problem. The one we use for this kind of problem is called simplex. Make sure from this menu you select simplex LP. Any questions so far? Makes sense to everyone how to set up the problem and how to translate it into Excel. And then once you did the objective function, decision variables, and constraint, select a method to solve. You can say solve. It gives you the solve it, keep the solve solution, okay. It says the best way is produce 26 of A, 36 of B, your total profit is 274, and you see you use all of the resources. Available resource of machine 1 was 160, usage is 160. Machine 2 150, you use 150. This is the best possible solution. And you cannot get profit more than this one. This is the highest profit you can get, and this is your decision. Any question about, makes sense? Anyone got different result? This is the optimal solution for this decision-making problem. Question? For example, let's say you are going to invest in and purchase another machine 1, and your machine 1 availability would be, because it would be 320. If you go and solve it again, go to data. I just changed the availability of machine A to, I did some investment, purchased another machine 1, therefore the capacity is twice. The available hours is, instead of 160, is 320. If you go and solve it again, because everything is there, I just need to solve and keep it. You see, it says produce none of A, produce 75 of unit B, your total profit is 300. And you see, usage of machine A is 225. Usage of machine B is 150. Which I have two resources, machine A and machine B. Now in this problem, which one of them is bottleneck? What is the meaning of bottleneck?
Machine 2. It's the limiting factor.
Yeah, exactly. The one, if I increase machine 1 capacity, is not going to help me, because I have, for the best decision, I already have 75 hours idle. I don't use that machine for 75 hours now. Because I invested not wisely, I increases the capacity of machine 1, but I don't need it. But machine 2 is bottleneck. Machine 2 is where if I increase it, I may get the better profit. You can play with this kind of decision making to see, for example, which resources is critical for you now. For example, maybe if you are in another setting, maybe you think it's better to hire new staff, or maybe it's better to increase for example, add some more computer or more technology to your business. There are some kind of resources with playing with the capacity and see how the objective function and profit and decision making change, you can get some insight about what is the best course of action you need to do for investment, for expanding the resources and things like that. Questions so far? No? Okay. This is so far, I explained the problem, we solve it, we translate it to Excel, we solve it. Now I want to write the mathematical formula for that. If I want to write this formula, this model in a mathematical equation, I tell you why we want to do that. Because for some complex problem, it's better to have the mathematical formula first, then develop the Excel formula. Because it was almost a straightforward and simple question. I could directly go and solve the problem. Let's see for this formula, what is the decision variable? I call it decision variable. Decision variable is number of item A that need to produce and the second decision variable is number of item B to be produced. The first thing is you need to identify the decision variables. What is that you want to make a decision about? Then the second, this is the first step. Can I call this one x1 and x2? Just name, instead of calling them the line name of number of item A to be produced, I say x1. Next time I tell you x1, you say x1 is number of item A to be produced. Next time I tell you x2, x2 is the number of item B to be produced. Yeah? Happy with that? Because some people, they don't like notation. But just for simplicity, I call them x1 and x2. We call it notation. Okay, the second part of the model is objective function. What is the objective function here? Is profit. I want to maximize the profit. Can I show the profit with Z? Instead of saying profit, I call it Z. Yeah? Short name for profit is Z. Yeah? Okay. Can anyone help me to write the formula for, what was the formula for profit I put here? You remember I had a cell here, it was here, believe me. Something here, it was this times 5 plus this times 4, yeah? Can I, 5, you remember profit here, that we had a formula for profit. Was amount of the unit, number of unit A to produce times profit of unit A plus number of unit B to produce times profit of unit B. Can I write it here? Profit is, Z is 5 times x1 plus 4 times x2. Yeah, instead of saying 5 times number of unit of A plus 4 times number of unit of B, I said 5 times x1 plus 4 times x2. This is objective function. Then I have some constraints. The first constraint was availability of machine 1. This was my first constraint. It was available for 160 hours. Initially, let me change this one to 160. And let's solve it again. This machine was available for 160 hours. What is the usage of machine 1? How I calculated the usage of machine 1? I write it first, then maybe you can follow, then I try to explain it. It was 2 times x1 plus 3 times x2, and it said it should be less than or equal to 160. Why 2 times x1? Producing x1 or number of units A I produce needs 2 hours of machine 1. And producing each unit of B, which is x2, needs 3 hours of machine 1. Therefore, 2x1 plus 3x2 should be less than or equal to availability of machine 1, which is 160. Make sense? This is exactly the formula I put in the Excel. Now we try to furnish it, put it some mathematical equation behind that to make it formal presentation of the model. And for machine 2, we had 3x1, because this coefficient is 3, plus 2x2, because this coefficient is, I'm talking about these two. Producing each unit of A, which is x1, needs 3 hours of machine 2. Producing each unit of B, which is x2, needs 2 hours of machine 2. Therefore, this is the amount of usage of machine 2, and it should be less than or equal to 150. The last thing I had was, because we cannot have a negative value for decision variable x1 greater than 0, x2 also greater than or equal to 0. This is exactly what I did in the Excel. This is the form modeling part of that. If you want to write a model, this is if for example you give it to anyone now, they do not understand what is the problem. First you have a problem, you translate the problem to this form, and then you put it in Excel and solve it. In this case, because it was a small problem, I created Excel for you to explain this first. Then you have the problem, you translate the problem to this one, and then change it to Excel and solve it. Next time you saw some, for example, or you see, for example, if people, or maybe they put it something, some people they put it like that. If you look at the book, maybe they put it like that, for example. This is the, for example, more formal rotation. Here also they put, instead of constraint, some people put subject to, ST or subject to. Let me finish this part, and x1 plus 2 x2 50, x1 and x2 greater than or equal to 0. This is again shorter version of that. You see, this, some people put it exactly. This is maximize z, objective function profit is this, subject to, or this is constraint. Subject to is another word, subject to this constraint and this constraint and this. Make sense to you this? Just put them in a line together. What was the question? No, we don't do that because usually we use the notation for variables. If you do that, it makes confusion because they are not our variable. Yes. Yes, you can do that. You can put it 0 and then put it as a y and then obtain that as decision variable as well. Yeah. This is the how. This is correct, that is correct, and what we did in Excel also is correct. Any question about this problem? This kind of decision making? If you don't have question, I want you to, again, if you go back to the lecture note, because the example in the lecture note is here. I want you to formulate that in Excel and write the mathematical model for that too. There is a manufacturer who built two products. A standard bag, let's see, I don't know whether it's cement or not. Let's say it is cement. Cement manufacturer, they can create a standard bag and the profit for a standard bag is $10 per unit. They can create deluxe bag and the profit is $9. And for that, they have cutting and cutting department, sewing department, finishing department, and inspection department. And this is the available hours of each of these departments. And if you go to the next slide, previous slide, it says for creating a standard bag, you need 7 on 10 hours of cutting department, 1 on 2 hours of sewing department, and 1 hour of finishing department, and 1 on 10 hours of inspection department. Based on these two slides, I want you to write the model, this slide and next slide. This is the problem. Let me know if you don't understand the problem. We have 4 departments in the manufacturer, and this is the availability of each department. And there are 2 products. This is the profit of each product per unit, and this is the coefficient or amount of usage for producing each of these units. I want you to, based on these 2 slides, write the mathematical model. Write mathematical model in the more explained way. What is decision variables? What is the objective function? What are the constraints? And then solve it in Excel. If you don't have a computer, you can work as a group and together, it's better to work as a group to discuss, make sure everyone getting there. First, say what is your decision variable? What is your objective? What are the constraints? Do you need to, I can turn the light on because some of you are writing. Great. Try to say what is the decision variable and then outline your constraint. Then put it in the mathematical formulation and then put it in Excel as well. very similar to what we did. Give it a bit thinking.
Profit is. So usually each one comes up with the less one is the one you pick. Does that make sense? And then you go with that total times 10 plus that times 9 for each bag.
Did I block your view for this?
Huh?
Did I block your view for this?
No, no.
Yeah, I'm
No, no.
Yeah.
All good.
I think
Duck.
I'm asking because I'm gonna take it from you.
Yeah, man, no worries.
Did you make it for all lecture?
I did it for week 9 and this one. I should have done it for all of them, but like we got halfway through and then I went, shit, I should have done it.
we're just gonna get the answer. Oh yeah, I said that. So this is the max you can use, right? Max amount of time you can dedicate per month to this.
For next week.
Yeah. So the constraints are less than equal to this time. Constraint 24. Okay, yeah, we got it.
Added that, yeah.
Okay, so your profit equals 10 times standard plus 9 times deluxe. That's your profit. Total profit, max profit you can make. Now, all of these are constrained to So that's your final product. These constraints for that, like I said, per bag,
So it's this.
7/10 times 630. Oh, sorry, this is the total. Yeah, so this is total, so 630. Less than equal to. S is dead. S is deluxe. That's your first constraint. This can't be greater than equals that. And then the same thing. Yeah. Yeah? So the same thing. And these are all your constraints for your profit maximizing thing.
The assignment 2, I put the result by Monday. We finished almost the marking, we just putting them and made them. And maximum mark is 35 out of 35, minimum is 15. This is what I remember. The average I think is down to 26, 27.
How much did it have?
Out of 35. But you will see your mark on Monday.
Why?
Or maybe a bit earlier, depending on if I can get some work done on the weekend.
What?
We will. We'll get 34, 35. Why are you so pessimistic?
Is that model?
You can't make a model think.
Yeah, but it's
Oh my god. Okay.
It's fundamentally dumb.
What? can't do that. I tried. You do know that me and my dad sat there for 3 hours. I spent 2 days on it. You can't do an inverse parabola. Because the data, I did a scatter plot. It wasn't like that. It wasn't a cubic either. You should have done a regression model. Good luck. It was really hard. Trust me. It looks really easy that at 1 hour put out there. I spent 2 days on it, and I spent 3 hours with my dad, and I was in bed crying. I'm like, this is not working. All of my R squares were coming up as like 0.00005. So I got it to like 2%. I was like, that's it. Stop now. Whatever. Yeah, 2%. So 0.02 is 2%. Yeah. Got it up. And all of my significance F tests were coming in 0.3%. So I'm like, it needs to be underneath 0.05 for it to be even considered. So, trust me, it went through like 10 regression. And we were like, I'm gonna get 35, and then the other assignment, I'm gonna get like, which is the data. Because she came out of the class, which I completely don't like. She said, anybody else to do the dealer session? I was like, I'm going to get all my resources and do this shit. I'm like, because she got 4 months for a new trade test. I was like, that is impossible. I don't know how she did it. I was so pissed. Because you don't like her. Just in the dealing session, like, it was table 2 and she was table 1. I'm like, clearly see the phone read. Just pick the damn thing up. Pick the damn thing up. I need to trade with you. I know what you want. And exactly what I'm going to sell to you. She would have picked it up. Because of her, I didn't reach my objective. She wanted all my short-term bonds, and I'm like, you can have it. I want all your long-term bonds. It would have worked, so then I ended up block trading with the other guy, which is completely illegal. But I'm like, the next 5 deals, I'm going to do 20 mil. This rate. Oh yeah. Some actually don't done their phone. So I hate her. So I have to do that. Yeah, that's all the constraints. That's all the constraints. That's how we want it, didn't you? And then you have to do it on Excel.
Assignment 3. We talked about assignment 3 next week. It's about course revision and all.
Next week we talk about assignment 3, the structure of that, and it's about course revision. No, I cannot change the date because I announced it from the beginning of the course, and lots of people make the arrangement based on that. No, we cannot put it on the weekend because it's similar to exam. I cannot put it start day or end date in the weekend because it's similar to the exam. It should be in the working hours. It's a limitation of the university. For example, you cannot have final exam on weekend. If I give you weekend, it shouldn't be counted in 72 hours that you have.
Because I have an exam the day after.
I have lots of limits, constraint.
Because this thing is the second one's hard, the next one's because the thing is, this report is 30%, but my exam is 50%.
If you do it once yourself, I think you get completely know what's going around the Excel and how to formulate it.
Everyone was like,
If I solve many times here, still before you hands on that,
I need my GPA to stay at 3.
doesn't help. Therefore, I encourage you, please do that, and then we check it together. Again, put it in the, after writing that, put it in the mathematical form as well, x1, x2, things like that.
I really want 30. What are you doing next? Finance? If you're going to do finance and need a textbook, please ask me. So if you do next year, you pick up business design, we're doing the same semester.
Each one you can take now. Yes, you cannot be text.
It's a core subject.
Formula.
Yeah, I'm not good
Calculated formula.
Yeah, that's right. Okay, I don't straight off the bat.
Yeah, no, but I was just like, the only issue that's
This kind of techniques first developed in the World War II when they want to make a decision where to bomb and where to assign the soldier to kill more people. It wasn't the good purpose, but now it's very useful.
they have to go design a business. The only issue is I don't know any money. It kind of scares me a little bit. I went to gym.
Had a long.
I'm just not looking for it. I just know my husband's going to gym, so customer service every day. He's not quite the mental stability.
Jake, did it?
No, I'm still. I missed that bit that you did, like where you do the constraints. How did you do it?
Just put the usage of constant and then I
But
show
I
you the
mean,
formula.
yeah, sorry, the
I show you the formula.
No, we have
The formula of usage of the constant. Number of units that we use times usage of the each constant for the machine. This is the what we did. If you need the formula, some people they even don't need that.
trust me, definitely not for me.
More time or I solved it. We need more time, yeah. More minute and then I solve it.
more.
I went and splurged it on tacos. I went to
See,
Let's go.
to doing that together. First, you can do it with me as well on your computer to make sure decision variable. The first decision variable is how many standard bags and also the second decision variable is how many each of the product. Yeah, let me look at the coefficient as well. We want the profit for the standard bag is 10, for the deluxe bags is 9. This is the decision variable we want to, and we want to maximize the profit. If this is the value that I want to make a decision, I just make them yellow for this one as well, yellow. The profit would be, if you look at this slide, $10 for a standard bag and $9 for deluxe bag. Is $10 times a standard bag is equal to 10 times a standard bag plus 9 times deluxe bag. Yeah, this is the profit. Because I don't have, let's see, put some random number. I put here 1 and 1. The profit is 19. This is my profit. And let's see, I have some constraint as well. I have a limit availability of cutting department. Then we have availability of, I have 4 constraints, which are cutting, sewing and finishing and inspection. Finishing and packaging or inspection and packaging. Each of them is available for 630. This is available for 630 hours. This is for 600. The other one is for 708 and 135. 708 and 135. For example, maybe if you want to schedule the emergency department in hospitals, you have different resources. You have specialists, you are available usually less. You have nurses, you have more resources for nurses. You have some doctors, you have different resources. This is this kind of, you can translate that like that. Let's see, and then we have usage of cutting department. And usage of sewing department, usage of finishing, and usage of inspection. For example, we have 135 hours of inspection because you don't usually hire too many inspectors. You usually hire more people for production. This kind of reason. What is the usage of cutting department? If I produce 1 unit of standard and 1 unit of deluxe bag, the usage of if I look at the coefficient, for the cutting department, each unit of the standard bag needs 7 on 10 hours of the cutting, and each unit of deluxe bag needs 1 hour of cutting. 7 on 10 and 1 hour. Yeah. Therefore, here I put here 7 on 10 times x1 plus 1 times x2. Here you can put 7 on 10 on bracket to make sure it doesn't mess up with the order of calculation. Because each unit of a standard bag needs 7 on 10 hours of cutting department, and each unit of deluxe bag needs 1 hour of the cutting department. This is the usage of cutting department. 7 on 10 times x1 or cell B3 plus 1 times cell B4. Make sense? Let me check that we have. You see here, cutting department for each unit of a standard bag requires 7 on 10 hours. Each unit of deluxe bag needs 1 hour. 7 on 10 of a standard bag plus 1 of the deluxe bag should be, this is the usage of cutting department. How about this one? The second sewing department is 1 on 2 hours of standard bag and 5 on 6 hours of deluxe bag. Therefore, here I can say 1 on 2 bracket 1 over 2 times standard bag plus 5 on 6 times deluxe bag. This is actually usage of the resources that we have for this problem. For finishing, the coefficient are 1 and 2 and 3. Is 1 times amount of standard bags plus 2 and 3 times finish bag. 2 times finish bag. Yeah. This is the usage of finishing department. Okay, for inspection department, again, same thing. Inspection, the coefficient of 1 on 10 and 1 on 4. It is 1 on 10 times standard bag plus 1 on 4 times deluxe bag. I can click on you if you want to see the formula or formula to make sure we are on the right page. Now we have profit and we have the usages as well. Any questions? Make sense to everyone? Okay. Now if you put, for example, 100 standard bag and 100 deluxe bag, I don't know why it doesn't update. I need to click on. This is the usage of my resources. For 100 and 100, my profit is $1,900, and this is the usage of the each resources. That decision is feasible because we can do that. Yeah, because we have 630 of the cutting department, we use 170 of them. We have 600 of swing department, we use 134 hours of that. This is a feasible solution, but it is not the best solution. It is not the solution that maximizes our profit, give us the highest profit that is possible. Everyone got the same thing, people who are doing that on the computer, they got the same. If you change it to 100 and 100, you will see, you can change it to any number and see. But for this, to making that optimal, you need to go to, again, data and solve it. The first thing is set the objective function. The objective function is this set. We want to maximize this one, and we want to maximize that. Make sure you click on maximize. We want to get the highest profit possible. By changing variable, here the variable I want to change to make the our decision variable. I want to make a decision by changing those two variables. How to change those two to get highest possible profit is possible. Then add constraint. The first constraint is usage of the cutting department should be less than equal to availability of cutting department. Usage should be less than availability. This is the first constraint. Click OK. Add again usage of the finishing department less than equal to availability of swing department. Swing. Add again usage of the finishing less than equal to availability of finishing. Okay. Add again usage of inspection should be less than equal to availability of inspection. We have 4 constraints because we have 4 resources. Make sure you keep the constraint are positive because we cannot produce negative number of bags there. And make sure you select the method simplex LP. If I click on solve, error. You got error too?
No. Maybe this is there. Oh, it's created.
You got error or not? I think excuse me.
No. Yeah.
You got error or solve?
In your variables, your top variable's blank.
You got the answer. Anyone got error?
No.
What's your error? What's your error? Same as me? You are unlucky person. Let me see why it gives me error.
It's in your variables.
Too many variables it
No,
says.
you've got a blank variable in the
Insert again data solver, maximize of this one by changing the value of these two by adding the constraint. This should be less than this, and this should be less than this, and this. Minimize and putting simplex and solve. No, it's solved.
That's it.
7,680. Maybe because first time it gives me error on the memory of my computer. Hashim, check, maybe you got the same thing. But this is the solution. You need to produce 540 of first bag, standard bag, and 252 of the deluxe bag. And your profit is 7,668. Tell me which department is bottleneck. Which, if you have some money, you want to expand some of the department, which one you are going to do? Cutting, yes, because cutting is limited. We use all of the capacity, 600 available, 600 used, but sewing, we are still underutilized. Finishing, you are up to capacity, and inspection, we are underutilized. Therefore, the cutting and finishing are those two departments that you better invest on to expand. Okay. Any question? Everyone got the same answers? Questions? Anyone use these techniques at workplace anywhere or the place you work? Do you know anyone using these techniques?
We will now.
Where?
We will now start.
Yes, you now? Either at work? Really? But for example, I had a colleague a few years ago who did a project with Qantas. They wanted to do the scheduling of it's very common model in the scheduling of the flight and things like that. But for those kind of models, it's not that easy to write. Maybe you need to spend 1 month to write the constraint. They had, for example, for one of my PhD students also working on the similar problem for the blood bank, for the scheduling of the blood to the hospitals. We wrote the optimization model. We have 32,000 decision variables. And we have more than 600,000 constraints. When you work with the real application, this is just for, it's getting very big, it's getting very large, it's exponentially getting larger and larger. And maybe sometime for solving that, you need to leave your computer overnight or maybe 2 or 3 days to just run to get the solution. And one of the things that advancement that people who are working in this area is how to get you remember we select this LP Cplex algorithm? There are lots of algorithms and people are developing those algorithms to make it quick. For example, if Qantas want to make a flight scheduling and they build a model, it takes one night to solve it, maybe it's not good enough for them because they want to use it maybe hourly. They want the model to give them solution in 1 hour. Some people are working to reduce those solution time. There are very active area of research, for example, at the moment. Some good people are working on these things now. Okay, let's move on and see how you can write this mathematical model for this. If you go, this is the mathematical model. Maximum of 10x1. x1 is the number of standard bag, x2 is number of deluxe bag. This is the objective function. We want to maximize 10x1 plus 9x2. The first constraint is 7 on 10x1 plus 1x2 less than or equal to 630. If I show it you maybe at the beginning of the class, it was a bit scary, but I'm sure most of you now understand how it's written. Just we change x1 and x2, name it for the number of bag produced from a standard bag and deluxe bag, and this is the 4 constraint, and this is the non-negativity constraint for x1 and x2. Makes sense to everyone, this one, how to read this? If you see that one next time, you don't scare, you see it's very easy to read this one. You have objective function, you have constraints, and you have decision variables. Make sense? Any question about these equations? X1 is number of standard bag, X2 is number of deluxe bag. This is the constraint for each limitation. Before I forgot, if we go back to the solution, this.
Slide 25 is the same slide. Why is it
24.
no, 25?
In slide 24.
No, 25.
24.
25.
This is this
25.
25. Same thing, but it depends on how they create the spreadsheet. But the way we did, I think, is easier. This is 24. Oh, 25 in your handout. Which one is 24? What's that? This is another way. We have this one as well. If you call it x, if you call it d as a, this is another. This is the formulation. If I call a standard bag x1, a deluxe bag x2, there is another way. If you call not, if you don't like x1 and x2, if you want to call a standard bag with the letter S and deluxe bag with letter D, it's same thing. It depends on how you name the decision variable. Maybe if you say x1 and x2, exactly if you put S x1, put D x2, it's exactly the same as the other one. Different naming of the variable. This is also makes sense as well, but in most of the case we use x1 and reduce index x for x1, x2, but this is okay as well. When we talk about the decision variable, we have the first thing you understand and translate the problem to decision making. It was okay to understand what is objective function, what are the constraints, what are the decision variable. But sometimes it is not very straightforward. Let's see, I think we have one example here. Look at this slide. It's slide 43, or maybe it's in your handout because there is one example of investment portfolio. You have some amount of money and you want to invest in different project or different investment option. You want to see how many or how much you invest in each of the options. This is the. You have $100,000 for investment. There is a company, they want to invest $100,000, and this is the option. They can invest in Atlantic Oil, and they think they expect rate of return for that project is 7.3%. This is the expectation of return from the first one. For example, Pacific Oil, the rate of return is 10.3. For the other options, this is the rate of return for different projects. If I give you this one without any things, you say, which one you select? You say, go and put all of $100,000 in Pacific Oil because it has a higher rate of return. But why they don't do that in portfolio management?
Risk.
Risk. Because I don't know. There is some famous quote. I don't remember that. You don't want to put, if you put there and you don't achieve that one, you done. But investor usually try to invest in different options. It's not good idea to go with the highest one and say I want this one, because if that's failed, done. But that's why they always is not to maximize the profit. You want to maximize the profit while minimizing your risk. Make sense? Okay. But assume there are some limitation as well. Some of the, for example, some of the investment they don't accept, for example, less than 50,000. Some of them they have limitation. You have to, for example, purchase at least 10,000 or not more than 70,000. There are the limitation in there. For example, neither industry, oil or steel industry should receive more than 50,000. This is the limitation that they have for the investment. Therefore, these are your constraints. If you define, let's try to do it. Try to translate this one to the mathematical model. The solution is here, but I want you to first think about that, do it, and then we can do it together as well. You have, the company gives you $100,000 to invest. This is the options. So far, you have decision variable, you know the profit, but these are the constraints as well. There are some text here that tell you you have some constraint. You cannot do whatever you want. What is the best portfolio selection you do? Go ahead and write the model. You can do it in Excel, or if you are now easy for you, you can write the model. X1, X2, maximize things, minimize. You have $100,000, and this is your option. How much money you invest in each of them? Maybe, for example, you say you invest 20,000 in the Atlantic oil, 30,000 in Pacific oil, and 50,000 in Harbor Steel. This is one option. Before this course, how you do this decision? Yeah, it's very important.
AO plus PO plus MS.
Really? How you do this?
That all of these should not be less than, should be less than equals 50 grand.
So they're separate.
Then you have two, so 2 oils and then 2 steels. A equals K, yeah, and then you go 50 grand is less than equal to, and change. So this is what you go. This is less than 0.025 bonds. 0.4545. Project rate of return. Yeah, so the amount you invest, which is 0.045 times government bonds, should be less than 0.002. Do you know what total return is? So the whole return. Yeah, so 100K is equal to
in the lecture slide, there are something about graphical method and sensitivity analysis, but I don't expect you to, if you are interested, you can read it from the book as well, but in terms of this course, I expect you to know how to write a Excel and also write a mathematical model.
Well, right. So investment. So, yeah.
Oh, this come on, the answers. Yes.
sort of change it. Right. All right. Cool. No.
Okay, let's look at the.
Seriously.
This is the how we define the decision variable. We define X1, amount of dollar invested in the Atlantic oil, and X2 for the second option, third option, fourth option, and fifth option. And this is our objective function. We want to maximize 0.073. This is the rate of return. 7.3 was rate of return for the Atlantic oil times X1 plus the rate of return for the second project times X2 plus the rate of, this is the profit you want to maximize. Again, once you have them in Excel, it's very easy to construct this function. Yes, and then we have the first constant is very important. Amount of the investment in project in option 1 plus amount of investment in option 2, option 3, option 4, it should be equal to $100,000 because your total budget is $100,000. You want to spend all of them. Then you know that you cannot invest in the oil more than 50,000. Therefore, oil is X1 and X2. X1 and X2 should be less than equal to 50,000. X3 and X4 should be less than equal to 50,000 as well. It's written here. Oil industry should receive, for example, here if you read it, it says oil cannot have more than 50,000 investment. Still cannot have 50,000 more than 50,000 investment as well. Oil is X1 and X2, and steel is X3 and X4. Therefore, the first line translated to these two, constraint 2. X1 plus X2 should be less than equal to 50,000. X3 plus X4 should be less than equal to 50,000. Again, it says amount of investment in the government bonds should be at least 20% of the steel industry investment. Therefore, investment in the government bond was X5. It translates to X5 should be greater than equal to 0.25, 20% of X3 and X4, X3 plus X4. And if you read the last one, it says the investment in Pacific Oil, the high return but high risk investment cannot be more than 60% of total oil investment. Therefore, X2 should be less than equal to total oil investment is X1 plus X2. X2 itself should be less than equal to 60% of X1 plus X2. Each of those sentences can be translated to these constraints. Please read those sentences, see, can you find a connection? It says X2 is risky. Because it's risky, we put the rules less than 60% of total investment in X1 and X2 should be in X2. Therefore, X2 is less than equal to 0.6 of X1 plus X2. And if you put all of them together, this is the maximum of this is the objective function, and this is the constraint, and the last one is non-negativity of the investment. You cannot have negative investment in any option. The first constraint is for availability of fund. Total available fund is 100,000. The second one is total investment in oil should be less than 50,000, one of the rules. The third one is total investment in steel should be less than 50,000. It was another rule. The fourth constraint is government bonds. Investment in government bonds should be greater than 25% of the investment in steel. And the last one is because Pacific oil is risky, investment is Pacific oil should be less than 60% of investment in oil. If you have this one, then you can go ahead and implement it in Excel and solve it. If we have still 15-minute time, if we finish, after this one we finish. If you want, you can try to implement it in Excel and check it together. Next week in tutorial, we have some tutorial question about this kind of problems. And in lecture, we review the course and I tell you about the structure of the last assignment and review some samples. The exam or the take-home exam is on week 13. I think I put the date. Make sure you make yourself available at least 1 or 2 days of those 3 days to do the assignment successfully. If you can do that, I will be around to help you. Otherwise, you can go. Therefore, if you want to stay, please do. You have the formulation, just a matter of implementing that in Excel.